Hey Finxter, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about Python's XOR operator. So we have an XOR is short for an exclusive OR operator. This is part of my series about all Python operators, and one of them you need to understand is the XOR operator. And good, so in the previous video we have learned about the OR operator, and the OR operator works on integer numbers and performs bitwise. So the bitwise OR operator performs bitwise, so checking for each bit of a certain sequence of bit whether at least one of those two bits at a given position are 1 or not. So the most simple case if we have a sequence with 1 bit. So we have simply a simple bit which is either set or not. If it is set, it is 1. If it is not set, it is 0. So let's have, for example, let's apply the XOR operator. It is this small hat symbol, and we can apply it on, say, 2 0 bits. In this case we would read 0 XOR 0, and the result is 0 as well. Okay, so the XOR operator returns 1 if the two bits are different. Okay, so we have an exclusive OR. It is an either or. You can think of this as an either or. So for the either or operator or exclusive OR operator, if both operands are the same, so if they are both 0, then of course either the one or the other would be 0 as well, would be false as well, right? But if if one is set, so for example, if the first bit is 1, the other one is 0, then the either or operation would actually result in a true Boolean value, right? So if you have, so for example, true XOR false, then we would have the return value would be true as well. But if both are true, then the either or operation is not true anymore, right? Because now both are true, so it is not true that either one or the other is true, because both are. Okay, so therefore the XOR operator basically checks if the two bits are different, right? And so for example, in this case, they are different. In this case, they are different as well, so the result is 1 as well. And in this case, what do you think? You can pause the video. It is, so they are the same. Okay, so these 4 are the characteristic exclusive OR cases on a single bit. And of course you can also, so instead of 0 you could write false, which is represented with the integer 0 in Python, and you could write false XOR true. You could write true XOR false, which would be true as well, and you could write true XOR true. Okay, no, true it doesn't recognize. So we have true XOR true, and this is false because they are both the same. Okay, so these two are analogous, so you can use either one. Okay, so now you know how the XOR operator works on a single bit. But what if we apply the XOR operator to some integer numbers? Say we have the integer number 3 XOR, say 8, let's say 9. Okay, so then if we apply this, the result is 10, and it is not obviously clear why this is the case. And Python, so now you need to know that per default the XOR operator in Python performs bitwise XOR. Okay, so it basically transforms both integer numbers on which you apply it into a series of bits or binary numbers. And so now let's transform this. So this operation into a binary operation. So we have 3 XOR 9 is equal to, so I just loosely write this into the shell so that you can see what Python is doing under the hood. So basically this one, say we have a 5-bit sequence. We have, so now we need to transform the integer value 3, so decimal number 3, into a binary number. And so we could write it like this. Okay, so we have 1 times 2 to the power of 0 plus 1 times 2 to the power of 1, so which is 3. So therefore this one would represent the decimal number 3. And now we need to represent the decimal number 9, and again we have 0 1 0 0 1. So we have 1 times 2 to the power of 0, 0 times 2 to the power of 1, 0 times 2 to the power of 2, which is 4, and 1 times 2 to the power of 3, which is 8. So we have 8 plus 1 is 9. Okay, so this is actually what Python is doing under the hood. And now it checks. And by the way, you could have an arbitrary number of leading zeros here in this example, because it wouldn't change the outcome of the overall computation, right? So now Python changes. Python basically goes over all these positions. So I just remove the leading zeros now. So Python goes over each position and checks for this position whether both bits are different or not. So if they are different, it sets the output to 1. If they are not different, if they are the same, it sets the output to 0, right? So we have in this case the first position is 0 and 0, so therefore the output is 0 as well, because they are not different. For the second position it is different, right? We have the second position is 0 in one case, and in the second case it is 1, so they are different, therefore we set the bit. In the third position again we have 0 and 0, so they are the same, means they are not different, so we set the bit to 0. In the fourth position we have 1 and 0, so they are different, we set the bit. And in the fifth position we have 1 and 1, they are the same, so we don't set the bit. Okay, so this is the output as a binary number. Now we need to transform it into a decimal number, so we have 0 times 2 to the power of 0 plus 1 times 2 to the power of 1, so we have 2, 0 times 2 to the power of 2, and 1 times 2 to the power of 3, which is 2 times 2 times 2 is 8. So we have 8 plus 2 is 10, so therefore the output as a decimal number is 10. Okay, and you see this is basically what happened here in this operation. So we have 3 XOR 9, the result is 10. So far so good, right? So this is pretty simple for positive integers. What happens if we have negative integers? So say we have negative integers minus 3 XOR minus 5. Now the output is 6. This again, it is not obvious why this happened. It is not like in the OR operation or so you can immediately see why this happened. It is not one of the operands. It is like how does it determine the output? Basically it's the same as before. So we need to let's just copy this operation. I will just write the result into the Python shell now again as I did previously. So now we need to transform both numbers into binary numbers, right? So we now first of all transform the number minus 3 into the binary representation, and we use negative integers to do this, or also called complementary binaries. So we have we need to represent negative numbers, right? And per default, if you have say 5 bits and you would use all 5 bits in the way I described here, then all numbers would be positive, right? So we need to actually basically shift the usage of some numbers. So some combinations of ones and zeros we need to represent negative numbers, whereas some other combinations of ones and zeros need to represent positive numbers, right? And how do we actually do this? Yeah, we use the first bit as the indicator. So the first bit is 0, which means that the overall number is positive. If the first bit is 1, and actually that was why I actually added the 0 bit here in this example. And if the first bit is 1, this means that the decimal number associated to this binary number is negative, right? So the first bit indicates whether we have a positive or negative number. And now we just use this special complementary binary encoding, which I will explain how this actually works. Okay, so we need to transform the decimal number minus 3 to the complementary binary number, and we first of all, so we do this by first of all encoding the positive part. So we take the positive part 3 and we encode the positive part 3 into a binary into a binary number, which is say this one. So we have 0, 0, 1, 1. So we have 1 times 2 to the power of 0 plus 1 times 2 to the power of 1, which is 1 plus 2 is 3. So this one is the positive part of my previous computation. Now we reduce it by 1. And this is just the algorithm that works, because the number 0 is now considered to be one part of the positive numbers, right? So the value 0, if you have 0, 0, 0, 0, so the 0-bit sequence is considered to be a positive number. So therefore we have we have one more positive number as we have negative numbers, and that's why we need to modify this by reducing reducing it by 1 first before we do the flip operation, which follows now. So we first of all so basically we take the decimal part, we reduce it by 1, so we have 3, reduce it by 1, we have 2, we represent 2 as a binary number, and then we flip each bit. Okay, so a 0-bit becomes a 1-bit and a 1-bit becomes a 0-bit, so we have 1 1 0 1. And now you see, if you follow this strategy, you will always have a number where the first bit is 1. And this is exactly what we want to accomplish, right? We want to represent the negative integers with a bit sequence that starts with 1. And this will always be the case, because a positive number will always be represented with a leading 0-bit. And if you don't have a leading 0-bit, for example, if you have, say, 16, which is 1 0 0 0 0, then you would simply have to add a 0-bit initially in order to indicate that it's a positive bit. And if we do this, we will always have a set first bit, so we always have a negative number when flipping the bits, right? And okay, so now this is basically this represents the number -3, and now we need to do the XOR operation. So we have the XOR symbol, and we need to represent the number -5. So again, we take the positive part 5, reduce it by 1, so we have 4. We need to represent 4 as a binary number, which we did here. So we have 0 times 2 to the power of 0, 0 times 2 to the power of 1, 1 times 2 to the power of 2, 2 to the power of 2 is 2 times 2, so we have 4. So we have 4 represented as a positive. This one would be the positive representation of decimal 4, and now we need to flip each bit. So we have 0 1 0 1 1, and again we have a sequence with a leading 1 bit, so we have a negative number, and this negative number represents -5. Okay, so now these are our intermediary results. So Python internally recomputes these numbers like this, and now we simply perform XOR, bitwise XOR operation. So we have 1 XOR 1, which is 0 exactly. So then we have 1 XOR 0, which is, you can pause the video and try to figure it out. 1, yes. We have 0 XOR 1, which is 1. Then we have 1 XOR 1, which is 0. Okay, so this is the output of our XOR operation, and now you see it is a leading 0. So therefore, we don't have to transform it back to a positive number or so to really understand the number. This is just, this is just a positive number, and that's why -3 XOR -5 is a positive 6. So we have 0 times 2 to the power of 1 plus 1 times 2 to the power of 0 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2. So we have 4 plus 2, which is 6, and 6 is the result of our XOR computation. Okay, so now I hope you understood how you apply this to negative numbers. So the general strategy to convert a negative number to a bit sequence is you take the positive part of the negative number, reduce it by 1, flip all bits, that's it. Okay, and then you can perform the simple XOR. So XOR means, are the 2 bits at a given position different or not? Okay, so what happens if you have a list of numbers? So you have my list, 1, 2, 3, 4, 5, some numbers, and you want to combine them into. So you want to perform the XOR operation. Actually, you want to do 1 XOR 2. The result you want to take to perform XOR 3. You take the result of those 3 XOR combinations and want to apply it to XOR 4 and so on. So you actually want to reduce all those numbers to one number by repeatedly applying the XOR operation until you get one result. You can use a NumPy library to perform this. The NumPy library has a nice function called Bitwise XOR. You could reduce an iterable like a list, or you could also pass a set here, and then you see the output is 1. And I'm not going to go over the computations. You can do it as an exercise. It is just like it does exactly the same as before, as we have discussed before, repeatedly for all numbers. Okay, next one is next, maybe what I want to discuss is XOR Assignment Operator. So we have, say, two numbers, x1 and y2, and we want to perform XOR and store the result in the variable x. How do we do this? We can simply call the short, so basically the long form variant would be x equals x, y. So we basically first sorry about that. So we basically first perform x or y and store the result, so override the variable x after performing this computation. So this is a long form, and the short form, of course, is to just use the XOR assignment operator. So we have, it's similar to plus equals for the plus operator, only now we have the XOR equal operator, and this basically overrides the first operand of this two symbol operator, which is called a bitwise XOR assignment operator. Okay, and this basically overrides the value of x. So x previously was 1, now it is 3, and y remains unchanged. Okay, so this is a bitwise XOR assignment operator, and now I want to discuss one important thing, and that's the bitwise XOR overloading operation. So how does this work? If you have your own class, say you define a class data, and the class has a constructor, takes one argument or one attribute, data attribute. This can be, for example, could be a number. And now you want to create you want to store two pieces of data, of your custom data, and what you actually want to accomplish is to perform an XOR operation on your two custom data items. So if you do it like this, if you run the code, you get an type error, unsupported operand types for our XOR operation, data and data. Why is that? So now we try on so x points to a data object, so an object of class data, which is a custom object, and Python does not know how to perform XOR operation on custom objects yet, because we haven't told Python to do it actually. So how can we accomplish this? We simply override the dunder method XOR with a reference to ourself. This is always the first argument of any method is a reference to the instance itself on which you call it, the instance itself on which you call it, and then we have a reference to the other object. And now, based on those two objects, ourself and the other object, so ourself is x and the other object is y. Based on those two references, we want to actually compute a new data object. Okay, so we return something. What do we return? We return a new data object. So we use a constructor data, like here, to create a new object. But now we need to fill in some data. So that's actually the data we filled in is the logical XOR operation on our data attribute. So how can we accomplish this? We simply call self.data, which is our own data item, this one, stored data attribute, and in our case 3, and we perform XOR on other.data. So on the other, this one is a reference to our variable y, or in this case y, and we have y has the data attribute 4. So we actually perform, in our example, 3 XOR 4, but you can use it on all custom data types. Now this one, each time you use this XOR symbol here, Python basically internally executes this dunder XOR method. It is also called magic method, and now this allows you to customize the behavior of your own objects that you define in your Python code script. So if you run the code now, the error message should disappear, and we get an and as a result we get data object, which is not like, this is not yet, it is not beautifully printed to the shell, right? It is not, so basically it just gives me a reference to the memory object of the memory address of our custom objects, because it doesn't know how to represent our object in the Python shell. So we can actually override another, define another dunder method called str for string. We can pass a reference to ourself, and then we simply return a string value by converting, for example, our attribute, and then we can have some suffix, for example, say underscore data, something like this. So this is string concatenation. So this is now our string representation of our object, and maybe even more beautiful would be if you have data plus with an opening parenthesis and a closing parenthesis. So now if you run the code, we now get the representation data, and we have 7, because 7 is the result of our XOR operation. Now let's check this. Again, we have used 3 and 4, so we perform 3 XOR 4 internally. So let's check whether this was really the correct result. 3 XOR 4, the correct result is actually 7. So therefore our we can now perform the XOR operation on custom objects and even print the result to the shell. So print the custom object to the shell, and the custom object will be then represented by the string data and the attribute data stored within the data instance. Okay, so I think that's beautiful, the overloading operator in Python, and I think with this we close this video. Thanks for watching, taking the time watching this XOR introduction in Python. I wish you well and see you in the next video. Bye.